This week we'll be studying the urinary system, and your book starts out with functions, but it looks like Dr. Lin has kind of amended the PowerPoint for this, and I'm actually going to stick with his amendments. The reason why is because it looks like the book goes into a lot of detail about urine formation, and he kind of tightened that up a little bit and made it a little bit more simple and 3 steps that are easier to follow than your book. So I still want you to read in the book, but it's not going to follow this PowerPoint exactly like it has been in weeks past. So we're going to look at the organs of the urinary system, and then we'll focus on overall functions. So the organs of the urinary system: the kidneys, 2 ureters, the bladder, and the urethra. And those are going to work together for the functions of the urinary system. And the urinary system works together with other systems. It works closely with the reproductive system, the digestive system. And so it's kind of going to feel shorter, but it's only because we've kind of touched on it in those other systems, and we'll continue to see how it works together with the digestive system and the reproductive system in the next few weeks. So here's where all of those organs are. This shows you both sides, anterior, posterior view. So 2 kidneys, 2 ureters, the urinary bladder, and the urethra. And we're going to see how that looks a little bit different in the male and female, how there's a few differences, but mostly just similarities. And then this shows you how the positions of the kidneys are sitting within the body. This kind of give you a posterior view. Well, not really posterior, but. So this says the functions of the kidneys, but really this is the overall functions of the urinary system. And here it says eliminates waste, and that is really the whole overall function of the urinary system. But that feels like a very short statement, except that it's really not. I mean, there's quite a few wastes to be considered here. And also I wanted to clarify between just the word waste and the word metabolic waste. Waste means anything that your body is not going to use, so that your body needs to get rid of it. Specifically, some of these wastes can be toxic if they get left in the body and they build up. And then a metabolic waste is specifically a waste substance that has been produced within the body. So that is something that the body has gone through some type of reaction, and over the course of the reaction, one of the products or 2 of the products are considered a waste product, that the body doesn't need those, and it has been produced within the body. And then you also might see the phrase nitrogenous waste. That means that the waste has nitrogen-containing compounds, and the most common, by 50%, is urea. And so again, if these nitrogen compounds kind of build up in the body, it is considered toxic at a certain point. So this just says eliminates waste, like, woo, that's easy. But we're talking about nitrogenous waste and others, and it is mainly the kidney that is doing this. Now, even though we have more than just the kidneys, we're going to focus on the kidneys the most in this system. They're kind of doing the most work. Everything else, the kidneys are actually doing the creation of the waste or the filtering of the waste, whereas the ureters, the bladder, the urethra, that's just kind of transporting, storing, and so the kidneys are really doing all the work. So not only are they eliminating waste, they are also regulating the blood volume and pressure. We'll see closely when we look at the kidney how that happens. They help regulate the osmolarity of the body fluids, so how much salt and sugars and that kind of stuff leaves the body versus how much stays. And they also control the blood pressure and the electrolyte balance. They secrete a hormone that stimulates the production of red blood cells. They keep the PCO2 and the acid-base balance for those body fluids, and then help in making the hormone calcitrol, which we talked about in the bones for calcium homeostasis. And then in extreme starvation cases, they go through the process of gluconeogenesis, which makes glucose from amino acids in an extreme case. So not every day, just in extreme cases. Okay, I'm going to save the rest of this, but as you go through this PowerPoint, you see that it doesn't really correspond with the reading. So the next video is going to be about the anatomy of the kidneys, and then we'll move into the function of the kidneys in more detail.